So we also develop various different kind of computation devices for the computing. Some of them can do the addition, subtraction. Some of them can do these multiplication, division, something like that. And the concept of doing the computing to remember these numbers and do the computing, the concepts are quite similar like today's computer. Okay, so as early computer pioneer Charlie said, at each increase of knowledge, as well as on the contrivance of every new tool, human labor becomes abridged. Okay, in fact, the earliest documents we find today, they use the word computer. This word doesn't mean the devices, the computing devices we use today, it call it computer. In fact, it doesn't mean a machine. It was a job title. Okay, it means the person who did the calculation. We call them computer. So the earliest documents we found today to mention the word computer was from 1613 in a book by this Richard Braithwaite, who written this book and came up with this word computer. Where this computer referred to some person who did the calculation means a job title. Okay. Okay. So until 1800 until that year, the computer referred to a job title, right? And after that, in fact, it refers to some machines who do the calculation instead of the human beings. So we can check this history development.
These devices was the step reckoner built by German polymath Gottfried Leibniz in 1694. Leibniz said, "It is beneath the dignity of excellent men to waste their time in calculation when any peasant could do the work just as accurately with the aid of a machine." It worked kind of like the odometer in your car, which is really just a machine for adding up the number of miles your car has driven. The device had a series of gears that turned. Each gear had 10 teeth to represent the digits from 0 to 9. Whenever a gear bypassed 9, it rotated back to 0 and advanced the adjacent gear by 1 tooth. Kind of like when hitting 10 on that basic abacus. This worked in reverse when doing subtraction too. With some clever mechanical tricks, the step reckoner was also able to multiply and divide numbers. Multiplications and divisions are really just many additions and subtractions. For example, if we want to divide 17 by 5, we just subtract 5, then 5 again, and then we can't subtract any more 5s. So we know 5 goes into 17 3 times, with 2 left over. The step reckoner was able to do this in an automated way, and was the first machine that could do all 4 of these operations. And this design was so successful, it was used for the next 3 centuries of calculator design. Unfortunately, even with mechanical calculators, most real-world problems required many steps of computation before an answer was determined. It could take hours or days to generate a single result. Also, these handcrafted machines were expensive and not accessible to most of the population. Before the 20th century, most people experienced computing through pre-computated tables, assembled by those amazing human computers we talked about. So if you needed to know the square root of 8,675,309, instead of spending all day hand cranking your step reckoner, you could look it up in a huge book full of square root tables in a minute or so. Speed and accuracy is particularly important on the battlefield, and so militaries were among the first to apply computing to complex problems. A particularly difficult problem is accurately firing artillery shells, which by the 1800s could travel well over a kilometre, or a bit more than half a mile. Add to this varying wind conditions, temperature and atmospheric pressure, and even hitting something as large as a ship was difficult. Range tables were created that allowed gunners to look up environmental conditions and the distance they wanted to fire, and the table would tell them the angle to set the cannon. These range tables worked so well they were used well into World War II. The problem was, if you changed the design of the cannon or of the shell, a whole new table had to be computed, which was massively time-consuming and inevitably led to errors. Charles Babbage acknowledged this problem in in 1822 in a paper to the Royal Astronomical Society entitled Note on the Application of Machinery to the Computation of Astronomical and Mathematical Tables. Let's go to the thought bubble. Charles Babbage proposed a new mechanical device called the difference engine, a much more complex machine that could approximate polynomials. Polynomials describe the relationship between several variables, like range and air pressure, or amount of pizza Carrie-Anne eats and happiness. Polynomials could also be used to approximate logarithmic and trigonometric functions, which are a real hassle to calculate by hand. Babbage started construction in 1823, and over the next 2 decades tried to fabricate and assemble the 25,000 components, collectively weighing around 15 tons. Unfortunately, the project was ultimately abandoned. But in 1991, historians finished constructing a difference engine based on Babbage's drawings and writings, and it worked. But more importantly, during construction of the difference engine, Babbage imagined an even more complex machine, the analytical engine. Unlike the difference engine, step reckoner and all other computational devices before it, the analytical engine was a general-purpose computer. It could be used for many things, not just one particular computation. It could be given data and run operations in sequence, it had memory and even a primitive printer. Like the difference engine, it was ahead of its time and was never fully constructed. However, the idea of an automatic computer, one that could guide itself through a series of operations automatically, was a huge deal and would foreshadow computer programs. English mathematician Ada Lovelace wrote hypothetical programs for the analytical engine, saying a new, a vast and a powerful language is developed for the future use of analysis. For her work, Ada is often considered the world's first programmer. The analytical engine would go on to inspire arguably the first generation of computer scientists, who incorporated many of Babbage's ideas in their machines. This is why Babbage is often considered the father of computing. Thanks, Thought Bubble.
Okay, so at the first beginning, in fact, you can also see from this figure, most calculation was done by women. So at the very beginning of development of the computer, there would be some computer scientists are very excellent women computer scientists.
These devices was a step record.
Okay, so until the 19th centuries, the computing devices, at the first beginning, the computing were only used by for the army to, for example, calculate to create some weapons or something like that for the wars. And then till the 19th century, the computing devices were used for some special purpose tasks in the science and engineering, but rarely seen in business, government, or domestic life. That is in some special domain. And here we see a picture. This picture shows the world's first general purpose computer, and its name is ENIAC. Okay, so this is the what we have recorded that the first general purpose computer till today. And we can see from the figure it is a computer that is very huge, but in fact it just have 8,000 transistors, but it weighs 30 tons, and it needs 170 square meters for its body, and the calculation speed is 5,000 times per second. We can see today the computer or the smartphone of each of you have a much faster calculation speed than this computer. And this first general purpose computer, ENIAC, was born in the university of this from this university, and from this 1946. So you can see how the computer developed from the very beginning. It's very huge, and the calculation it weighs so much, and the calculation speed is not very fast. And then you can say nowadays we also have some supercomputers. However, their calculation speed could even be the petaflops. And this shows the Summit supercomputer from the America. And this shows Fukaku computer. It's from Japan. And this is from China, Shenwei supercomputer. All of these three computers have ever win the top 500 computer, the winner of the top 500 computer supercomputer of the whole world. All of these three has ever been the first one, the first number.